Hi everybody. Welcome to the sixth and final session of SWIP 25 called Protocols and Standards. I'm Adrian Pohl from HBZ and I'm moderating this session. We will start with Péter Király, first talk. Peter is a cultural heritage, digital humanities software developer and researcher, the member of Göttingen eResearch Alliance. As a researcher, his main interest is quality assessment and statistical analysis of cultural heritage metadata. And he will present on Shacl4Bib, custom metadata validation of library catalogues. Peter, the floor is yours.
Yeah, thanks, Adrian. Welcome. So several presenters of this SWIP edition already mentioned quality-related activities. Moreover, Professor Panigaputra Roberts explained that what she learned from previous SWIPs. I will talk about a particular piece of semantic web toolbox that I found reusable in the non-semantic world of data. So this talk is also what have the semantic web ever done for us kind of presentation. I will not suggest anything that moves forward the semantic web libraries per se, but I report about backpropagation effect. So the Shapes Constraint Language, or shortly SHACL, is a formal language for validating RDF graphs against a set of conditions. The problem SHACL tries to solve is that semantic web builds on the open world assumption. Shortly, we do not have a schema that provides restrictive rules about statements in a given context. SHACL and its implementations provide a dictionary and machinery to create such rules and validate statements against them. This is a simple example. The person shape defines rules of a person node. Each person should have one and only one, max count is set to 1, social security number denoted as SSN. That should be a string, the data type property, and match a regular expression, 3 numbers dash 2 numbers dash 4 numbers. This is the pattern property. I should mention an alternative approach called SHACs, or shape expressions. For those who are interested in applications of SHAC on semantic library data, I highly recommend the collected works of Gustavo Candela. Today, however, I will not talk about the direct application of SHACL or SHACs. So most of these properties I mentioned in the previous slide are meaningful for other data types. What is really semantic web specific in that is how SHACL tells which data element, the nodes and properties in an RDF graph, we should take care of. We have, however, similar mechanisms that can select a data element in non-semantic web data. We have XPath for XML, JSON paths for JSON, column names for tables, even the core bibliographical metadata schemas and serialization formats have such tools, MarcSpec for MARC and UNIMARC and PICA paths for PICA. With orchestrating these existing tools, it is possible to implement the non-RDF specific subset of SHACL to a wider range of data. So I implemented this idea in the already existing tool, the Metadata Quality Assessment Framework. The idea, I call it Shacl4Bib. It keeps cardinality-related constraints such as minimal and max count, value ranges, constraints against strings, comparisons of data found in the records, and logical operations. So these are the existing constraints in the SHACL. While working with real data sets and metadata practitioners, it became evident that we should introduce additional constraints and properties, such as checking the content types of URLs or dimensions of images, giving descriptions and identifiers to individual rules, hide or skip them, and setting dependencies between them. Shacl4Bib not necessarily should concentrate on data problems. It also ready to find the good practice. The user can assign different scores for success and failure criteria. For example, if a given property have a string value that is the minimal requirement, it is better if it is a link to a term in a known dictionary, and even better if the dictionary is a supported one by the current organization that runs the analysis. It might be familiar for those who knows the 3 years of Europeana's publishing framework. These rules can be set in a schema that describes all metadata elements we analyze, so it does not necessarily describe all the elements available in the metadata schema. This schema in the example can be expressed via a Java API or YAML or JSON configuration file. This particular one sets that the file to analyze is a CSV file, and we are interested in a single property. There should be one and only one URL, and it should start with HTTP or HTTPS. So you can see that the same is defined with 3 different serialization. This presentation is not intended to be a tutorial, so I will just give you some starters. With numeric value constraints, we can require that the value should be greater or smaller than a given scalar. With combination, we can set value ranges. We can set constraints for the length of string value. We set a list of acceptable values. We can create a regular expression and set the minimal or maximal number of words. We can compare data element values, such as the title should be different than the description, which is a frequent problem in aggregated collections such as Europeana, or the first page number should be less than or equal to the last one. It is possible to combine these rules with logical operators. For example, there should be one and only one identifier, and it should contain at least one character. So this one. As mentioned before, real-life scenarios required to extend the original rule set. Here are 4 of them. Checking the content type that issues an HTTP call. Checking if the value is unique. That requires preliminary indexing that is also part of the tool. Setting dependencies between constraints. For example, check values of an optional element only if it is available. And finally, checking dimensions of an image. Here we said that the image should at least 200 pixel per 200 pixel. After this short introduction, I will talk about 3 use cases where we use this approach. The first one is German Digital Library, shortly DDB, an aggregator of almost 1,000 cultural heritage organizations in Germany. The Shacl4Bib supported quality assessment process intends to support the validation of incoming records that the partner institution submit to the database. DDB accepts several metadata schemas. In the current phase, we worked with Dublin Core and LIDO, but this is a special Dublin Core adapted by DDB. The tool analyzes each record, then aggregates the results, and finally displays them in a dashboard. The dashboard provides both record level and aggregated overviews. Here is a fair compliant one. Here are 4 types of outcome. Green means success. So for example, here 92% of the record match the requirement. Gray means not acceptable, so not applicable. So it is applied when the data element we would like to check or validate is not available. For example, it's an optional element. And orange means failure, that we still can live with it, while red means failure that blocks the ingestion process. So if we run into a red one, then DDB doesn't accept the submission and ask the data provider to fix the issues and submit the file again. In the rule definitions of these, only the addresses or the data element is different. Both are expressed with XPath in this scenario. Note that the Dublin Core, we check 2 distinct data elements with 1 rule set. So not just a single one, but the same rules can be applied for multiple data elements. The second use case is the nightly quality assessment of the catalog of KBR, previously known as the Royal Library of Belgium. Several years ago, they introduced this new name based on QA catalog, a tool that extends Metadata Quality Assessment Framework. The metadata experts of KBR maintain the schema file that validates MARC 21 records and uses the MARC spec language instead of XPath to specify fields, subfields, indicators. The validation concentrates on the changes that come with the recent introduction of RDA in the cataloging practice, and the special requirements of the library comes from its existing customs and special situation. The dashboard, similar to the previous one, allows the users to check individual records having a particular problem or a good example. The Shacl4Bib approach eliminates the need of writing software code for validating the records, but still writing configuration file or a Java code is not a user-friendly approach. Together with other quality assessment experts from the University of Marburg and Verbund Zentrale des GBW, the maintainer of K10 Plus, the largest German union catalog. Within Aqinda project, we work on a tool called Contrainify that provides a kind of wizard for metadata experts. Instead of starting from scratch, the user can select human-readable sentences typical in constraints definition, such as for element X, each property Y does or does not contain a specific term. These sentences are distilled from documents describing metadata requirements created previously by partners such as DDB, KBR, European, and British Library. The user then should fill the gaps with concrete metadata elements and scalars. The tool now supports only TI and LIDO, but we plan to extend it. Helps it by providing autocomplete and generated list read from the metadata schema and its documentation. Once filled, the user has constraints like each actor has at least 1 birth date, or for actors, each education contains master of. The user then can execute the validation with the selected constraints and visit the reports. So that's it. If you would like to know more about Shacl4Bib, please consult with these resources. I'm happy to hear about your suggestions and critique. Happy coding and have a fruitful SWIB for the rest of the day.
Thanks, Peter, for your interesting talk. Let me check. There's one, not really a question, but a comment in the chat. Interesting idea that validation provides relative scores. String is not an error, but concept URI is a better value for property X. So
yeah, just one comment to this comment that different issues are not equivalent important. They're not equivalently important. So there are more important issues and more heavy issues than others. So, for example, a typo is less important than a missing identifier.
okay. And there was another comment. Yeah, I think Jakob linked to some an attempt to define addressable data elements across many formats. Yeah, I'd be interested in the UI you created. How many people have used it, and what were the reactions to it? The
Yeah,
UI you show.
We are just finishing the first phase of the project, and so far it is kind of a demo application. We asked partners, about a dozen persons, and asked them to use and give feedback to us, but it is not yet used in production system. If you would like to use or give it a try, then here the aqinda.gvdg.da, you can find the instance and you can play with it. And also, if you would like to try on your computer, we have a Dockerized version.
Thanks. Yeah, I think you already uploaded your slides, so people can look up all these links.
Yep.
Are there any other questions? I don't think so. So yeah, then I'd say thanks again for your talk, and more Q&A can happen in the chat or on the topic of your talk in the forum. And I suggest we move on to the next talk.